and welcome everyone to the monthly Kong community call. Great to see you all. I'm really excited for this session. Narendra and the team at Egnyte built a fantastic plugin. And why I really love it is so many people think about rate limiting as the number of requests over an amount of time, but that's never really the limitation. A lot of the time, it's about how much bandwidth you're sending. Now that cloud providers are charging for ingress and egress. So when we saw the plugin that Narendra and team built for the Kong Summit Hackathon, we knew we were onto something special. And they actually ended up winning the best Kong gateway plugin overall. Now, Narendra's here today to talk us through how they built it, how it works. So I'm just going to hand it straight over to him.
Okay. Thank you, Michael. Thank you so much. So hi guys, Narendra here. I work as a senior DevOps engineer at Egnyte. And I'll be talking about download limiter, which is a plugin which helps you rate limit based on bandwidth. So I have a small slide deck on that. I'll just share it. Let me know once you guys are able to see this.
Looks great, Narendra.
Okay, so a brief about download limiter. So download limiter is a plugin that will help you rate limit based on your bandwidth consumption. Okay, now why on bandwidth? So there are a couple of reasons that so now primarily most of us are on cloud, and on cloud you're charged for ingress and egress. So the amount of bandwidth that gets utilized, your cost is proportionate to that. So high bandwidth consumption could lead to very high costs. Also, you do not want a particular client to exhaust all your bandwidth and throttle the customers. So you'll want a fair usage of your bandwidth to be divided between different customers. So that way you'll give a fair service. Your service, you'll have happy customers, and you can keep a control tab on your costs as well. So these are a couple of use cases for which the download limiter plugin can be helpful. So that's the primary use case of a download limiter. Some of the features of download limiter that we'll talk about. So download limiter helps you rate limit based on bandwidth consumption. So you can configure it according to any customer, user, or any particular entity that you want to bandwidth rate limit. Like you probably want to rate limit a user, or you'll probably want to rate limit a customer, or or a particular domain. Like you can use any custom entity to rate limit as long as it's part of your request. Also though you rate limit, but there would be specific requests from that entity or customer that probably are of higher importance or higher priority, and that you'll probably not want to rate limit. So this plugin gives you an option to that also, to exclude or include specific requests only for rate limiting. And on weekends, like most of the customers you have less utilization on weekends, so you have more bandwidth, and if you want to allocate that to customers that are high bandwidth, who consume high bandwidth, then this plugin also offers you ability to provide them extension on weekends. Like you can provide them extension on weekends so that they can utilize that more, so that you do not have free bandwidth at your end, like your bandwidth gets utilized. Also along with that we provide support for jitter. So configurable jitter is a thing wherein you can let your customers before and know that they'll experience rate limiting, and as such they can just back off and only run critical services that are of importance to them. For example, let's say if you have configured a customer to rate limit on 100 GB and you configure a jitter of 20%, that's so post 100 GB utilization of that customer, their random requests would start giving them start getting rate limited. And so that this will be allowed till a maximum of 20%, that's 20 GB. So after 20 GB utilization, everything would get rate limited. So customers would have, or your entity whatsoever you configured for rate limiting would have those 20 GB bandwidth available, during which they know that they are getting rate limited, and as such they can back off non-critical services and run only critical services that they know should be are important for their business or daily use BAU. So that way, we also provide option for jitter. So how does this plugin work? So primarily this plugin works on the basis of a header in the incoming request. So you can use this header to identify your customer, your user, or any particular entity, as long as it's part of the request. So if you can see here, while enabling the plugin, we specify the header, which header would identify our entity or customer. So like X domain is the header which will identify our entity which we want to rate limit, and in the response we'll provide them X rate limited header, so that they can know that they're getting rate limited. So we provide them in the response we'll get a 429 status code indicating you are rate limited, along with that a header of X rate limited, so they know they are getting rate limited. Third is there will be another header called X retry after, that will specify the amount of time after which they can retry. Of course, this X retry after would have some sort of randomness to it, so that we avoid the thundering herd problem that all requests should not retry again at the same time. So this is how the incoming header can identify the entity which you want to rate limit. But so now you have this header against which you want to rate limit, but what would be the rules for that? So the plugin also provides you an API with which you can rate limit, provide rules for rate limiting. We'll walk through a demo where we'll see how we can apply this API, the plugin, and in whole. So you can see this configurations. We say the domain test. So whenever this header X domain contains the value test, this rules will be applicable. Again, this X domain is configurable while enabling the plugin. So you can configure your header, which will identify your customer. So whenever the value of this header in the incoming request is test, so this rules will be applicable. Now we'll just go through these rules. In these rules, if you can see, the match path is mock/200. So whenever the request path has this pattern, this will be eligible for rate limiting. This is the download limit. The limit we have set it in bytes, so we have set it to 1,000 bytes. So whenever the 1,000 bytes gets exceeded, the entity or the customer will be started experience rate limiting. This is extend limits for weekends. So we have provided 0.2. 0.2 is 20% of of your download limit. That is approximately 200 bytes of your 1,000 bytes. So after 1,000 bytes gets so on weekends, after 1,000 bytes get exhausted, you still have 200 more bytes allowed. You can even cap it up to one as well. Like if you want to provide 100% extension on weekends. Third is extend range. See, extend range specifies what percentage of download limit you'll want to provide your customers for jitter. So we have configured. So in this example, we have configured 0.1, that is 10%. So after 1,000 bytes have exhausted, they still have 100 bytes more, in which random request of there would start failing with rate will start getting rate limited. So they know that they are getting rate limited, and they can just back off and only run critical services. So extend ranges for that. Now let's say you have identified with your header the entity that you want to rate limit, but you might have certain priorities for certain requests, and you do not want certain requests to be rate limited, so you can exclude them. You can specify if you can specify the header and the pattern with which you want to exclude them. So let's say whenever your header would whenever the header with incoming header has an X header with the value as bypass, that request would be not eligible for rate limiting. It will be bypassed. And whenever the incoming request would have a header called X agent with the pattern limit, then that request will be eligible for rate limiting. So that way you can exclude or include certain requests for rate limiting. So that's how this is. Also a bit about performance and monitoring of this plugin. So what we do is we do not see to so we use Redis to store information about bandwidth consumption, but then again we do not see to Redis with every request. So what we do is we collect it into a shared memory and then seed it to Redis every periodically 30 seconds, so that we do not overwhelm Redis. So that's how we try to maintain this performance. Or in future versions, we also plan to implement Kong caching, so that will also give a more boost to that performance. The another advantage of seeding to Redis is that now we have this information in Redis via which we can plot graphs, and we can analyze our bandwidth usage pattern. You can see one such example over here, which we use at Egnyte to identify bandwidth consumption for our customers, like what entities are consuming what bandwidth, and that way we get the trending bandwidth trend for our usage, like so with the advantage of seeding to Redis is that you get monitoring as well, and that's about monitoring and performance. Now quick information, like how do we set this up. So since we seed to Redis periodically, so we run a timer in in the plugin, to seed to Redis. But the problem with the plugin is that normally the plugin parameters aren't available during the init by worker phase. So we have to do a prerequisite beforehand so that the timer could run. So that's one thing that we have to do with the prerequisites. After that, these are all the standard things, like standard plugin steps, like you install the plugin, you enable the plugin, and then you provide your configurations. So the rest are the standard steps by which which we normally use during our any Kong plugin setup. So that's the standard steps. So now we'll move on to a quick demo of this. So I have a local setup over here. It's running on Vagrant. So we'll just go through our example. I have an example over here. We'll just move through that. So like we mentioned the steps, we need to first do a bit of prerequisites. So in that prerequisites, we'll try to make this Redis configuration available in the init by Lua init worker by Lua block, so that it can seed to Redis. So there are two ways for that. One is by environment variables, or the other is by using a custom Nginx template. So we'll go with the environmental variables one. So in first we have to put this configuration in kong.conf. So I'll just open it up. So I've just put this configuration there. Then we have to export certain variables. Those will be using those values. So I'll just put them up. I'll just verify if we have this available. Cool. I think we have this variables available. Okay. And then now that we have this available, we'll go to the plugin installation step. We have this you can install this plugin in two ways. Either you can use the luarox command, or you can just clone this repository and do a luarox make from inside the repository. Both ways work. So now we'll just use luarox install, and we'll install the plugin. So the plugin has been installed now. And so after you install the plugin, you need to enable the plugin. So you have to configure in your kong.conf. So we'll just do that. So I will just so we have just enabled our plugin. So after we enable the plugin, there's one last step that we need to do is we need to run migrations, so that the services are, so we use a database to store information about domain. So the necessary tables or the necessary structure has been created. So we just run this command. So I've already run this once before on this setup. So this is already bootstrapped. So in your case, if you do it on your setup, you will have that migration run successfully. So now that we have done this, we'll just restart Kong, so that Kong is available. So we have just restarted Kong, so that the plugin is loaded. Now we'll move on to the example. To see our plugin in action. So in the README, you will have the example link to the example, where we can just go and try our example. So for the example, we'll first create a service. So the service has been created. So if you see, we have created a service named download-service. We'll also create a mock service, to which this will route the traffic to, so that we can, test our bandwidth utilization. Now we create a route that will route to our service. The route has been created. So you can see, /download is the route that will call our service, which will route the traffic to localhost 1001. We'll run a mock service to test it. Now we'll enable our plugin. You can see here, we are specifying the incoming header as X domain. So any request with this header, X domain will be eligible for rate limiting. We can always go ahead and change this to our the one which you require, which will identify your entity. So we'll just set this up. So we'll just enable our plugin. So the plugin has been enabled. So now the plugin has enabled, we'll do the configuration. So now we know that the incoming header X domain is what is eligible for rate limiting, but what rules we need to set against it. So we'll set these rules. So we have identified the incoming value as test. So whenever we have the header as X domain and the incoming value as test, then those requests would be eligible for rate limiting. So we'll just set this up. So we have just set that up. So now I think we are good to go. Just before that, we just have to run this mock service, so that we have an actual mock-up service available, so which you can test against. So I'll just go on to our repository where we have this along with example directory. So here we have the configuration for mock service, and we'll just start up the mock service. So the mock service is now available. So now we'll start some request to it. So what will happen is, when we send this request, Kong would, so you can see, right, /download. So any request on this route, /download will be passed on to our download service, which will pass it on to our mock service. So now we'll start sending some traffic to this. Okay, and observe what happens now. Okay, so we'll just send some traffic to it. So after some time, with every request, we calculate the amount of bandwidth that has been utilized, and we store it into a shared buffer, and in which periodically is set to Redis every 30 seconds. So you might face a max delay in rate limiting by 30 seconds, but that post that you'll experience rate limiting. So you can see, and we store this information in Redis. So here we'll find a key for it. The key would be created against this. So you can see 2012 12 14. If you get this key, and you can see what amount of bandwidth has been utilized, you can see 637 has been utilized, and our capping was, if we see, the capping which we have used was 500 bytes. So that has been exhausted. So we'll be experiencing rate limiting. If you see here, you can see that we have started getting rate limited. You'll see 429 status code, and you can see X retry after, which will specify that you can retry it after the 24 hours on the next day. So this also has a variability. We add some randomness to it, so that you don't get thundering hurt problem that all requests come together. So that's how you get rate limited. You can see now all requests would be getting rate limited. However, if you'll see, we have configured the rule for domain as test. So whenever the value of the incoming header X domain, whenever the value of X domain is test, only then that will be rate limited, so that you can only rate limit your customer entity that you want, and rest all can pass. So we'll just test that as well. So if I put your test 1, and you can see the request is passing, because we have just rate limited the entity test. So that is passing. Also you can see test is getting rate limited. Also you can see we have excluded specific header for rate limiting. So whenever we say internet integration user and the pattern is bypassed, those requests will be excluded from rate limiting. So we'll just try that out. So instead of rate limit, if I put your bypass, and let's see what happens. If you bypass, then that request will be excluded from rate limiting. Now if we go to our old request, and we again see that's still rate limited, only whenever the the things that are excluded from the request. So only those requests that will have this agent and bypass, that will be excluded from rate limiting. And whenever your header use an agent as a pattern for rate limit, those would be requests only that would be rate limit. So you can use them exclusively or together, or for combinations, like where you want only certain requests to be rate limited and you want certain requests to be bypassed. So that's how this plugin works. So that's it from my end. Post that, I think. Yep, I think that's it from the plugin end.
Thank you so much, Narendra. Does anyone have any questions for Narendra? Feel free to come off your camera if you'd like to, or you can enter them in the chat. Michael, do you have any questions or comments?
I do, but there is a question in the chat.
Ah, we got one. So let's see, Narendra, can you rate limit all requests without specifying what to limit in the request header?
Yeah. So you will have to specify. So you can just not put include or exclude, but then you'll have to have an entity against which you want to rate limit. So you can have a header called X domain, but then you'll have to have that one particular header to identify the entity which you want to rate limit. But apart from that, the include or exclude are exclusive, so you don't require them as such. But the incoming header is important. One thing, like that will identify what you want to rate limit against. That is a mandatory one, to identify what you want to rate limit against.
Excellent, thank you. Michael, go ahead with your questions, and maybe people will think of a couple more while you ask.
So I noticed you installed with LuaRox rather than compiling from source. Are there any advantages to using a pre-built plugin versus compiling from source?
Yes. So if you use a pre-built plugin, then the advantage is that if you compile it from source, then you'll have. So let's say if you have 10 different machines or nodes, you'll have to write your sort of automation that you have to check the source code at every end, then compile and then run it. Also, the advantage of pre-built binaries is that the source would be at a different end, like with new releases coming in. But if you want to stick to a particular version, you will always have that binary as well.
Cool, thank you. Does anyone else have any questions before I dive on with mine? Okay. So this plugin was developed during the hackathon, which means it's compatible with Kong 2.5 and 2.6. Should it work with all future releases? Like, is there anything special in this plugin where we need to keep a careful eye on it, or is it just expected to work consistently?
Yes, I think it's expected to work consistently. Though we'll test it with the newer versions as well. But there's nothing specific bound to a particular version that could hinder it being worked with other versions.
Cool. And final question for me. Are you and Egnyte open to receiving pull requests on this plugin? If someone sees it and thinks this is really cool, like Anjali, who would like to use it without specifying a header to rate limiting, would you be open to receiving pull requests that add features and schemas to enable that? Yes,
we are more than happy to accept pull requests. If for enhancement, it's because that's one of the reasons why we are open sourcing it. So everybody can use it and everybody can make contributions to it. So most welcome. Any PRs are most welcome.
Awesome. That was all of my questions. Any more from the team before we opened up for general Kong questions?
And just before we do that, just a comment, we will have, Narendra has also written a blog post on this plugin, so make sure you follow the Kong blog. We will be planning to publish that on Thursday, and we will have a link to this video as well, so you can share it with anyone who you think might enjoy this plugin as well.
Okay,
And
let's
with
open it
that,
up.
yeah, thank you so much, Narendra and the Egnyte team, for being here. We will open it up now, for any Kong related questions. This is an open forum and discussion, so feel free and ask anything that you would like.
Yeah. So, just before you open up, I just want to thank, Taryn, Michael, Teets, and everybody at Kong, for helping us out, reach, showcase our plugin and, helping us fine tune like with reviews and, with hackathon and helping us, reach out to different people, with this plugin. Thank you very much, guys. I mean,
absolutely.
No,
Thank you for participating. This is what the community is about. This was our first annual hackathon, and we hope to have many more in the future, hopefully in person as well next year at Kong Summit. So make sure and keep an eye out for hackathon and all of our community events. We love interacting and helping the community. So we'll keep it coming.
Yes. Thank you, Taryn, so much. And thank you for everybody who's joined in, for the demo. Thank you very much, everyone.
And just to add to what Narendra said, if anyone on this call or anyone that you know in the community wants to develop a Kong plugin, but would like a second opinion or a code review or anything like that, feel free to email michael.heap@konghq.com and we'll see what we can do. Like, we want to support people that are building plugins for the Kong ecosystem. Okay, we have a hand up. Let me just, Narendra, do you want to stop sharing your screen?
Yeah, I'll just stop sharing.
Excellent. Siddharth.
First of all, it was a very good presentation and plugin, Narendra. Thank you for that. So I have a generic question with respect to Kong, especially with respect to 2.6. We are running over Kubernetes, and we were using 2.4 and ingress controller 1.2. But I recently upgraded it to 2.6, and after doing that, I see that we are no more having this ingress control leader election, and I do not see a config map added to that. And after that, I mean, I've seen some weird errors where the proxy per se, multiple ingress controllers are trying to update the proxy and the database. And with that, I see a lot of errors, and sometimes the deletion doesn't happen. Is that something does that ring a bell?
That is a huge question for the call. I'm going to drop the GitHub repo into chat. If you could open a discussion in the Q&A section. There were some changes to the ingress controller. You said you went from 2.4 to Kong Gateway 2.6, but also potentially ingress controller 1.2 to 2.0. There's quite a lot of changes there. So I'd like to get one of the Kubernetes team involved to work with you on that one.
Of course. Yeah, I'll do that. Yep.
Awesome. Thank you. Any other questions? Well, any questions that we'll be able to help with, because I wasn't too helpful with that one.
So me again. So I have a question. So with respect to GraphQL, I understand that it is a more of a enterprise one. I mean, do we have any kind of roadmap where that could be introduced eventually in open? Will it be open sourced, or is there an idea behind that?
Which GraphQL plugin specifically?
Are you talking about the support for GraphQL is available in enterprise? Is that a fair assumption?
So GraphQL APIs can be exposed through open source as well.
Okay.
We do have some plugins such as dGraphQL, which you can use to convert a GraphQL endpoint in your upstream to a REST API, which is enterprise only. But you can expose GraphQL APIs through the open source version just fine. It's just another upstream.
Oh, okay. Okay. All right. Thank you.
Yes, and sometimes some plugins are moved from enterprise to open source as well. We have seen that before with Proxy Cache and some others, I think. So it's more of like a product question than engineering, I would say.
Right.
Yeah.
Yeah.
And I'm happy to represent product in this capacity. I'm actually on the product team here at Kong.
So I have a question. So we have a rate limiting plugin, right? So in that we have different policies like cluster, Redis, and local policies, right? So when we set cluster as a policy, will the rate limiting count be written into Kong's database, or will that be written into a etcd data store?
So if you're using the Kong rate limiting plugin, that is written to the Kong database, I believe.
Okay, so the documentation says it writes into data store, right? So it's not the etcd data store, right?
No, it's either Cassandra or Postgres. The cluster means that.
So for every transactions, Kong will look into database and then take the count.
I'm not sure if there's any batching. Actually, App or you.
Yes, so enterprise version of the plugin, I think it implements something like that, but it's also sliding window, so it's slightly different implementation than what we have in open source one.
Okay, so because we have rate limiting plugin set as cluster level plugin, and we don't have, when we run a transaction, right, we have the database running in different data center. Since, so the Kong has to talk to database running on different data center, and that is taking a certain amount of latency there. So trying to see if we can write it into data, etc data store instead of writing into Kong's database.
Yeah, right now we don't have the support for etcd, so you need to go with the Redis or something like that. Okay. But we are kind of like having this same issue with when we separate the control planes and data planes. So then the data planes cannot access the database. So we are kind of like needing to solve this ourselves as well to support better the CP/DP separation, where currently the data planes are kind of like DP-less nodes managed by the control plane.
Okay, sure. Thank you.
Any other questions? In which case, I'm going to hand it back to Taryn to wrap it up.
Sounds good. Well, thank you all so much for joining today. We hope to see you at our next online user meetup, which will be in January. So everyone have very happy holidays and a happy new year, and we will see you in January. Thank you everyone from Egnyte for joining, and Apo and Michael, and especially Narendra. Have a great day, everybody.
Thank you all. Thank you.
Thank
Bye.
you.
Thank you.